President. I'm just curious, for how many of you this is the first time you're here on campus? Excellent. Wow. You've gone so far.
Yeah, that's very, you've done so
well. Welcome to campus. Right now you're in part of the new science complex that we just recently dedicated. This is the older building that was recently remodeled, and when you came into the lobby before, on the other side is the brand new section. Together we have almost 200,000 square feet dedicated to the sciences here now, and most of the brand new labs are on the other side. So if you have a few minutes when it's done, you may want to just peek down the halls just to see what we have here. For young people, welcome. Hope you enjoy it. I can tell you this is a great place to be if you ever want to think about coming here. We have a lot of students here tonight that hopefully would say the same thing. And that's all I have to say. I'm glad that you're here. Sorry that the clouds didn't cooperate with us, so we couldn't bring out the telescopes, but I'm sure you'll enjoy the presentation. So, thank you.
Thank you. Welcome again. My name is, I'm just going to do that without, I like doing stage voice because my first master's is in astronomy and my second is in theater arts. So I've done a bit of stage work, and so I like using my stage voice instead for these kind of things. Welcome. My name is Jason Kendall. I am the NASA JPL Solar System Ambassador for New York City. I'm also an adjunct faculty here at William Paterson University in the physics department, teaching astronomy. And I have the pleasure of having my class here this evening. Tonight was their final class, and they've done a great job. I want to give them a round of applause for being here. This class is the first class to have had the opportunity to use a new purchase by the university. The university purchased for them a series of telescopes, about 30 Galileo scopes, small refractors, as well as 8 Dobsonians to look at the sky. And so we can hope that these clouds will part. And if they do a little bit after we're done here, I'll send them over to the lab, we'll grab a bunch, and we'll run outside and see if we can see just the moon. We just got to cross our fingers, but I know how it goes because I watched the weather for years, so we'll be mostly here. So I'm just kind of building it up to tear you down. It's all like that. It's going to be like that tonight, you know how it goes. So what I'd like to talk about tonight is a fascinating and wonderful thing that we live in. And it's kind of an odd thought, because in our world today, we tend to think of all the political problems, economic problems, blah, 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 blah. We can name them, they're legion, these problems are everywhere. But they've been this way. If you go back 50 years, they had problems this, problems that. Go back 100 years, problems this, problems that. But we actually live in what I would consider a golden time. And that's a weird thing to think about. And this time is because we have the capacity to learn the things that we can learn. We go back 100 years to when Percival Lowell turned a telescope towards Mars, and because the lens was so large that it actually reflected the image of his own retina on the image, so he saw the blood vessels in his own eye and thought there were canals on Mars. That's why he said that. He thought there was water flowing in civilizations on Mars. And people thought that for a long time, until the Viking landers went to Mars and showed that it was a barren and dry place, and the Mariner missions flew by and saw that it was a barren and dry place. But now we've landed on Mars with Spirit, Opportunity, Phoenix, Viking, and soon to be coming up, Curiosity, the Mars Science Laboratory, and these things tell us something new. Now we live in a time where it's not speculation about whether or not life arose on other planets. We can now test this idea. We can now go someplace, look inside other places in the solar system. We have the capacity, we have the technology, we can rebuild it. We can actually make this happen and go there and look. And so tonight, we're going to look at this first attempt, this first little attempt to step outside of our solar system, out of our little cocoon, the Earth, this wonderful little blue globe that actually is the only place where we know life truly does exist. And we're looking for if it ever started anyplace else. So let's look at an interesting thing. The first thing I'm going to show, I'm going to do a lot of videos and things, but I'm going to look at this. This is a flyover of a crater on Mars. Now, Percival Lowell, when he looked at Mars through a telescope, He actually thought he saw canals. This was back in the 1890s to 1930s. But now with the high-rise instrument on board the Mars Reconnaissance Orbiter, this is seen. The sides of a crater wall. Notice what's changing. See the dark flows? That's water. Subsurface water in a liquid state coming out from the sides of the canyon walls on seasonal variations and flowing down the sides of the slopes. The temperature on Mars is pretty cold. It's like 100 degrees below, but in the summertime in Mars is when these flow occurs. In the wintertime, they stop. In the summertime, they happen. This is new. This is new. Only in the last few years. This is actually a study over a couple of years, and if you look really closely, you can actually see that it actually moves. And I believe that I should be having audio here, and I guess I don't. Maybe it's just the view. But what we see is that those long flows, they're salty water. That's what we would expect on Mars at that temperature, and that's what's seen. This is new. We live in a time where we now know that water may actually be flowing in a liquid state on Mars. We don't know about this on any other planet except Earth. That's amazing. Now another thing, let's go look at this. I'm going to pop this up because, I'm not afraid of using the web. I'm not. I do it all the time. And I like to say that because, sometimes people when they're doing public talks don't like to actually go search the web. But I shall, because I want to show you this, let's see, Mars, because we have to look at this Mars image from December, APOD, and it'll be the Opportunity and Endeavour crater. There it is, boom, boom, boom. The rover Opportunity, which we saw in the previews with one of those little tiny rovers, this Mars exploration rovers, have been roving since 2004. Spirit, one of the two actually broke a front leg. Basically, one of its 6 tires got stuck, and so it had to drive backwards. As it drove backwards, it dug a little trench because the tires were designed to actually dig into the soil and have good traction. As it dug in, it unearthed things that were right underneath the surface. Right underneath the surface were white and yellow sulfate minerals. Salts and sulfates that can only be formed in water. Now, this is Endeavour Crater, which the Opportunity rover reached in December of last year, just only a few months ago. And if we look closely, I want to find a better picture of that, because I know what I'm looking for here. You're looking for this word, and I'm giving it away by typing it. Everybody looking? Oh, holy cow, where is it? Aha, that's it. It went into that crater. It just rode down in there, looked off to the right, and saw this. That is an outcropping of gypsum. Gypsum, calcium hydrated sulfate. Hydrated sulfate. The only way that that rock could have formed is at the bottom of a lake or a small shallow pool. We now know conclusively that Mars once had a global ocean covering the entire northern hemisphere of Mars. This is part of the evidence. The sulfate and salt minerals that are underneath the soil, just underneath the soil of Mars, also show this. Let's also go look in 2008 when we look at the Phoenix lander. You go Phoenix, and this again, you got it, holy cow, right? You can just type that in. Oh my goodness, holy cow! This is underneath the Phoenix lander, which its goal was to go to the North Polar region of Mars, land. It had a little arm. It was going to scoop and dig up some soil and look for subsurface water ice. People had figured it was there for a lot of reasons, because the north and south polar ice caps of Mars, which grow and shrink just like the Earth's does, is mostly made out of either carbon dioxide ice or water ice. And they figured right below the surface they might have to dig down a couple of feet with the thing to look for it. The jets from the lander blew the dust off of the ice. The water was right there, and that's water ice, right underneath the land. Mars has a lot of water in the form of ice, water vapor, under the surface, from Newton crater, in past geologic history and time. So it's really starting to beg a question, isn't it? And the question is, did life ever arise on Mars? And that's been one of the major topics of debate, a major effort in terms of science, in terms of planetary science. Fully half of the papers in the Department of Planetary Sciences at the American Astronomical Society in the last meeting they had were on astrobiology. In fact, a NASA researcher actually got into a lot of trouble recently because she decided to declare that there was a certain kind of organism that may actually have a different form of life that could be found inside of a lake in California, in a briny, acidic lake. Well, most people thought her research was bunk, and it got a big controversy around that, but that's not really the point. The point is that it's looked at believably, is that now we're actually looking out into the solar system, looking away from the Earth, and seeing what kind of life can exist elsewhere. One of the most interesting things we can do here on Earth is you can go down underneath the Antarctic ice, go down inside of this ice which hasn't seen fresh water in thousands, if not millions of years. You melt it out, you get bacteria. They've been there. You go down over in all the digging around that we do in a neighborhood to build out a building. You look inside the soil, maybe like 300 or so feet down, 100 feet down, 800 feet down. You dig out that soil, that rock. You put it in some water, give it some more bacteria. Boom, flows to life. You go also to the bottom of the deep sea oceans. At the right off the Museum of Natural History in New York City. I also volunteer there and give tours there too. It's kind of fun. There's a place called, there's an exhibit there that's unique to the United States, and it's at that museum. There's an exhibit called The Black Smokers and Sulfide Chimneys, which are at the bottom of the ocean. At the bottom of the Earth's ocean, a mile and a half down, no sunlight, no oxygen, but yet these sulfide chimneys, which have water coming up from heating by magma and flowing and getting into the rocks and bringing that minerals up out of the rocks and putting it on the ocean floor. There's bacterial life, there's fish, there's crabs, there's all sorts of crazy things. In fact, there's kinds of life that lives there that lives nowhere else on the Earth. Life finds a way to find places to live. So did it arise on Mars? We don't know. That's why you go. You want to find these things out. So, let's take a look. The Mars Science Laboratory was launched. It's the next big generation of landers that's going to Mars. Now, Mars is a very, very, very inhospitable place to go to. Fully 2/3 of all space missions bound for Mars have failed, crashed, or had problems on that. It's tough to get there. Mars is 1/3 the mass of the Earth and has a very, very thin atmosphere, which means if you want to actually get there, you have to figure out a way to slow down upon arrival. So the typical spacecraft, when it goes there, it arrives going about 17,000 miles an hour. To slow to a stop gently takes a little bit of trickiness. Because if you're going to slow down, what are you going to do? Retro rockets, parachutes? You don't have a big atmosphere like the Earth does, so you can't slow down like a big parachute. You have a thin atmosphere, you're going to be slowing down really fast. So let's see how Curiosity is going to get there. This is the next big orbiter, this big lander going to Mars, and this thing is about as big as a truck. 1-ton vehicle going to Mars. This is the launch of this vehicle, how it's going to get there. This was launched in Thanksgiving of last year. It's currently en route. It arrives on August 5th of this year at about 1:30 in the morning our time. So if you want to, get up in the morning and watch this. And if we're lucky, there you go. It did this successfully on that morning. So now this is the spacecraft that's on its way to Mars. And what it's going to do is they do a couple of course adjustments. It takes 8.5 months to get there. Planets must be aligned properly. And you can't get there any faster. Actually, you could, but you'd be going so fast that you couldn't slow down. So you have to go at the best possible way. The planets are all nicely aligned, so all you have to do is just coast your way to Mars. Launch it, coast it, get there. This is how it gets into Mars orbit. It'll be so far away, Mars, that a radio transmission takes 7 minutes to get here from there. This is all done robotically, what you're about to see, and takes 7 minutes to land. So first it comes in going about 17,000 miles, and has a heat shield, just like in the old Apollo days. You gotta slow down somehow. Directional stuff, technology to get those directions. It's actually like a cruise missile, directing it to one place on the planet. These little jets kind of move around. Now it takes another reading set, after it slows down to only 1,000 miles. These little jets are getting into the right place. Throws off a little bit of weight so it can spin again. Balance. Sonic parachute to slow it down about 200 miles an hour. Drops the heat shield. There's the rover inside. It's going at about 200 miles an hour now, slowing down. And it does this. It just does this. This is all done robotically. And here it goes. What you saw is what will happen on August 5th of this year. And it'll be sitting there, nice and gentle. 17,000 miles an hour to 0 in 7 minutes. Landing on Mars is hard. It's not like you can beam there. We don't got transporter technology. We don't have warp drive. We ain't got none of that cool stuff. But all we do have is what our current technology allows us to do. The Spirit and Opportunity landed with little airbags that actually bounced them to a stop. So the first thing that the Mars Science Laboratory does is it calls home. This mast sits about this high off the ground, and it'll take a series of pictures all around it to determine what its neighborhood looks like. It'll then beam back to the Mars Reconnaissance Orbiter overhead and send back pictures from home. If the mast camera, and see all those little things below it, it looks like a big eye. That's actually a laser beam. We'll see what it does in a bit. But all those cameras that are there, it's stereoscopic vision, so we'll be able to take stereo images of around, just like Spirit and Opportunity have done for the last 8 years. So what it'll do, and this is the machine, it's kind of cool, it's just a little robot. It's not a little robot, it's the size of a car. It's about a 2,000-pound car. Now it's powered, unlike Spirit and Opportunity, it's powered by a radioactive isotope generator. It's a nuclear reactor on board. And so it's beaming back home. It doesn't actually directly talk to Earth. It talks through the orbiting satellites, the Mars Odyssey and the Mars Reconnaissance Orbiter. And now it drives along. It says, where am I going to go? Once it's at the bottom of the crater, it goes, well, let's go someplace. So the next step is that it has a series of scientific instruments, many of them visual, because we actually can't go there. But what would you do if you were a geologist? You'd take a magnifying lens, you might collect some rocks, you would take some rocks, you'd take a little hammer, you'd smash open a rock with a hammer, you'd look inside with your loupe. And so, as the scientists were building the Mars Science Laboratory, what they did is they actually made it look and behave just like a field geologist would. So it has a long arm that's already curled up like this, but the mast actually is looking at things in the distance, such as the crashed parachute from the heat shield. So hopefully we'll be able to see that. And then it'll drive along until it finds something interesting to look for. What it will be looking for are not the sulfate minerals that were found by Spirit and Opportunity, but it'll be looking for sedimentary rock. Rock laid down by water flow. Because if it's searching for past evidence of life, it will be looking specifically for things that might have flowed in. Like if you have a lake and you have dead critters in it, they'll sink to the bottom. And they might form a mat. And in fact, if you go to the Museum of Natural History, you'll find a big rock that's in the Hall of Planet Earth. It's got these red bands and stripes along it. That's evidence of bacteria in the ancient Earth's ocean that actually metabolized rocks out of the water and settled it on the ground. So this is going to look for geologic evidence for past life. It's not going to go play bridge with anything. It's not going to go up and see and look. It has no capacity to detect, oh, I'm a bacterium, I'm running around. That's not what it does. It's not going to look for squirrels or people or little green men with funny looking eyes. And it certainly won't see anything like War of the Worlds or anything like that. The kind of life that it is looking for is bacterial life that may once have existed. Fossilized stromatolites in the Earth's crust are the types of things it's looking for. It's built with the machinery in order to look for it, and now it's like going on surfing along with it. So eventually, it'll come up to a rock outcropping that the scientists think is worth looking at. And so they're going to be communicating with it, and they'll say, okay, this looks like a good place. We see some sedimentary looking rock, and there's some outcroppings there. And it uses a laser in order to basically zap the rock and vaporize it. So that looks like a good spot. Now that laser vaporizes a bit of the rock. And the onboard cameras then look at the dust that comes from that. And as the sunlight passes through that dust, it breaks the light out into a spectrum, and it tells us what that dust is made out of. That's kind of cool. And if it likes what we're looking at, it has a big arm. And that arm is about the length of your arm. So it can reach around in the same way. Now, it's a robot, and that arm could go like this, right? Bonk, and knock its mask off. So this is kind of important because you could actually hurt, it could hurt itself. That arm is so strong that it actually can move like it can actually lift the rover. So you can actually break the rover apart by using this. But this is what it's really for. And this has never been done on the surface of any planet other than the Earth. Drilling into the rock, taking a sample, and using an onboard geologic laboratory that's onboard this spacecraft. It can take up to 76 samples of rock and analyze it. It's shaking it up a little bit, because when you take the stuff, you don't know how it's distributed. Shake it a little bit before dumping it into your can. Now this is interesting. Watch this. It's so little. Remember, this thing's the size of a truck. And it dumps it into the sample collection, and it's only just a pinch. Just a pinch. Less than a quarter teaspoon. You got to make it right. 76 samples, each a quarter teaspoon. And this is a standard method for doing sample analysis. So what this is an X-ray laser that when you beam the X-rays through the sample, the material that makes up the sample diverts the lasers out in a very particular pattern. It's called X-ray crystallography, and it's a common thing that you'll find in X-ray crystallography lab here at WPU. And this is actually how we know what the stuff is made of. So by using onboard sample analysis, which has never been done before to this extent, we will know whether or not organic material is fossilized inside of the rocks on Mars. And since it can do it 76 times, it'll have a number of opportunities to be able to go and drive around. Now, where it's chosen to land is the next subject. So we'll jump out of this. And we'll look at the other stuff. Hold on one second. So, Gale crater. Actually, I'm just going to go out here. and find it here, because there are some people who can say it a little bit better than I can. Let's see, how do I make it on the bird? So, okay, here we go. This is it. The next landing place on Mars is a place called Gale Crater. Gale Crater is at the bottom. It looks like a moat. Think of it as a castle moat. In the center of the crater is a 3-mile-high mountain, and this crater is a rather large crater. And that dark circle is where they're going to land the thing. They're going to land it somewhere inside that circle, which is only about a mile or so in diameter, and then they're going to drive up the side of this mountain and drill into the rocks as they go. So as they land on it, they're going to try to get centered on it. And that's why, as it was doing those jets as it came down, that's what allows them to pinpoint it there. Spirit and Opportunity had a 100-mile wide landing radius. That's only a 1-mile wide area. They've got to get it to the right place, because Mars Science Laboratory, because of its nuclear reactor on board, can only drive for about an Earth year. Not very long before it runs out of juice and it can't do its job. And it's done. The experiment's over. So the Gale Crater is the critical place to land. Let's see if we got this is it. And JPL has a series of stuff. We're going to do this. I'll just put this up real quick. So the choice of Gale Crater is a result of being able to see these multiple geologic features. And we'll show you where that lives.
I'm John Grotzinger, the project scientist for Mars Science Laboratory, the Curiosity rover, and we're going to take Curiosity to our chosen landing site in Gale Crater, which sits at the border between the southern highlands of Mars and the northern lowlands. A really exciting spot because it's very low, and that's the kind of place where water might have pooled and possibly formed lakes. So here we see a different view of Gale Crater that has a different perspective. You can see our landing ellipse.
All of these images have been given to us by the Mars Reconnaissance Orbiter and the Mars Odyssey
mountain
orbiter.
of rock.
So they actually know where they're going to land, and they'll drive one of these two paths.
But the layers at the bottom are the ones that we're most interested in, because we think that those were deposited in an aqueous environment, which is very important for understanding habitability. What you can see here now is that we're about to land very close to the center of the
could something
landing
have lived there
ellipse.
once?
And we have a couple of different routes that we can take. The scientists on the team prefer the one on the right, and so what we would do is drive along
They're
it.
actually going to pre-drive it. What we would
And now you can see at the base of this mountain where these lower layers are.
So
And the layers are
the
important
height on
because
which they're going to
they'll
go up the side of this mountain will go up a 3-mile high, 3 miles up in the air. From the bottom of this crater, going up these canyons, looking at various and sundry geologic strata, in order to dig into the rocks to see what actually went on in the past on Mars. So we're not actually looking for current life on Mars. We're actually looking for life that may have arisen 3 or 4 billion years ago. In fact, if you go to the Museum of Natural History, you'll find a series of meteorites in the Hall of Meteorites called the Shughati meteorites. These meteorites come from Mars. How do they come from Mars? Well, we have evidence of crater impacts all over the Earth, all over in every body in the solar system, and also from Mars. There's very serious talk that life arose first, and this is in the planetary science community, in the Mars community as well as in astronomical community, that life arose first on Mars, and in these shallow oceans on Mars, was then extinguished, but about half a billion years later. But before it was extinguished, meteorites hit Mars, and the bacteria took a ride to Earth. We might be Martians. We might be Martians. Here's how we'll know. If fossilized evidence is found of these bacteria on Mars, what they'll do is the next step is to actually send a sample return. So let me bring that. No. Oh, that's fine, too. They were just hearing about that. Let's see. Have we go up here. They always got something going. These guys know. My classmates, my classmates, they know that I'm always talking about this and diving into stuff and trying to figure this out. Right? That's how it always is, right? Woo! Yeah, you know how it is. So, and we'll do right hand sides. Come on, bring up. Site selection. So Matt Gollenbeck, who you actually heard just a second ago on there, this is from a NASA scientist. Let's go back a little bit. This thing's dumping on me here. Hold on. And there you go. I was actually on this on a talk with him as he discussed what they were looking for inside of in the Martian environment. What this slide shows is what opportunity the previous Mars exploration found. See those little black lines? What geologists will do is they map out rock. And so really what we're doing is we're looking inside the rocks. It's kind of crazy. We're going to space. We're doing spaceships so we can go look at rocks. Right? What's the whole goal? We've got to fly through space 17,000 miles an hour, land on another planet to look at rocks. Okay. So it's kind of a neat thought. But when the opportunity landed and found this particular crater, see those black lines? A geologist will look at a picture that he takes of rock, and they'll try to demark different areas inside of the picture. And we see these black lines showing where there's sedimentary deposits. The blue lines show different age levels, but the black lines show where there's definite lines where sediments were deposited. This is like cookie dough. Close-up images of this material looks like cookie dough. Those little spheres you see in there, those are hematite spheres. Iron oxide hematite. Hematite is only formed in the presence of water. When Opportunity landed and found this, it was like, wow, this is what we're looking for. Opportunity landed in the side of this crater, and that's what they were looking for to begin with. So, I want to show you this little wonderful quote that he has on here. Maybe we're all Martians. Because the Mars Odyssey, all these other things have shown not only was there water in this amount, and in fact it takes resources away from many other NASA missions in order to do so. But what they do is they're actually trying to show one major mission for NASA is to actually demonstrate the origins of our solar system. So when we do that, we actually spend money in order to develop technologies that then go back into our economy, which is a strange thought. How does this kind of stuff go back? Almost every one of the machines and devices that were built for the Maya Science Laboratory was built with private contractors, and they had to invent technologies to do it. So these inventions that will be used by these private corporations actually do other things. And you might have actually heard something recently in the news. Mining asteroids. That's new, that's not kidding, that's real. And so people are going to try to do that within the next decade or so. And there's high school students and grade school students in this audience who may learn that when they're in their 50s and 60s that they're going to be dealing with interplanetary property rights arguments. Okay, so you own this asteroid, but I got there first, and you can't have the material off that asteroid, so it's mine, and I'm going to go use it. So this is a definitive thing that happened. And now, if we look closely, we can say, well, all of the materials that were used to build, say, the Mars Science Laboratory, with the rover here, with all of these technologies that have been made for it, they actually fold back into our economy. So when you say, what does pure science do? Well, it makes jobs. That's a good thing. We all like that concept, so that's a shameless plug. I'm sorry. So here's, say, the entry, descent, and landing in kind of a graphic format. But when we look at it, we say, well, look, let's see. I just want to actually jump around a little bit here because usually the other crater locations that were looked at Marwood-Fallis, which has an enormous plateau, which was their actual preferred landing site. But as you can see, it's an extraordinarily rough location, and you can't actually get there easily. They would have probably crashed the lander getting there. So there's this competing thing as the scientists and the engineers decide. They say, okay, you want to go to this really cool spot, but the problem is, I can't get you there, because I'll crash you. It's like, well, we really want to go there. Sorry, not going to happen. Because Marwood Valley has these stratigraphic, the stratigraphy that they were looking at actually has materials that look like that there's an interface boundary between where water would stop flowing and where it came from. Essentially, we'd be looking at a river delta. We'd be landing in a river delta. What a more perfect place to actually go hunt for life than in a place where water pooled and formed. But you can't get there from here. You simply can't get there. So, Gale Crater, they actually took a whole bunch of images. The funny thing is as Matt Gollenbach, as a JPL guy looking at this, he said, my whole job was to actually tell the Mars Reconnaissance Orbiter team to fly over this and take me a zillion pictures. And they actually got resolution down so they actually could find rocks as big as this monitor. So they flew it low. They actually found things that are about 1.5 feet in diameter in order so that they could land the craft safely. Because the wheel deck is only about this high. A Hummer is a little bit higher than it. So it can actually drive over it. Those 6 wheels can go over stuff. But in order to actually land safely, you got to not land on a rock. And Gale Crater has this enormous flat plateau. And this, if you look closely, right there, see that? That's a place where water once flowed. That's a river delta. They want to specifically land there and actually start there, right there. This is the walls of the canyon here, and they say that there's some places they can't get up to because of the rough terrain, kind of like the Badlands of South Dakota, if you've ever been out there. I actually went out there once and nearly got gored by a ram when I left my car. It was really stupid. So don't ever get out when a ram is charging. So just FYI. So don't do it. Yeah, it's a bad idea. So let's see. We go back. Here we go. Open this up. So what I'm going to show you is some interesting stuff that we can do as a community. And if you want to, here's when you can go look at it. On this date, on April 5th, on August 5th, it'll be broadcasting roughly between 8 p.m. and 11 p.m. Pacific time, right? Well, this is kind of late. So we're going to be doing stuff all over the country as volunteers. But more specifically, you can go online to nasa.gov. And if you have cable TV, high def, you can actually watch it working in high def. It'll also be streaming at Ustream on that night. The schedule will be put up there so you can actually watch it. So this is when it's going to happen. So it's kind of late in the morning, in the night, you know. So I don't know. Were we planning on actually doing an event here at 1:30 in the morning? What do you say? We just put it up on the school up here. We ordered a whole bunch of pizzas and stay up till 2:30 in the morning. What do you think? That's a department chair. It's a department chair. What do you think? That sounds like a fun thing. Sunday August 5th, right? That'd be some kind of day. We'll talk about that. We'll see if we can organize it. I know it's like, look at the time though. It won't even land till 1:30. So we would actually see it go through. Now this is a lot of fun to do because we'll be seeing live broadcasts. And if you want to see what they did, here's what it looked like that day. Practice landing. Landing practice. This is kind of what we'll see on TV right now.
At this point, the vehicle should be warming up its RCS system and prepping to charge to entry to prepare the last few preparations for entry.
Today we did a test of the whole approach and landing, all the activities from cruise stage separation through the parachute deploy, through the powered descent, all the way to landing.
We're seeing heartbeat tones indicating that the vehicle is behaving normally and has nothing to report, so everything looks good right now.
And you would think it was actually landing day. We have everybody in their places with their, in front of the computers looking at what information they would actually see. Essentially, it's like a dress rehearsal of the whole mission.
Parachute deploy tone. The vehicle is now deploying parachute at Mach 1.7 and slowing down very rapidly.
We're simulating what the team will do and see as the vehicle lands on Mars.
We are looking
That guy did the
fuel separation
landing
and
operations for
separation
Spirit and Opportunity.
spacecraft.
We don't actually use the spacecraft,
In
obviously.
2004.
We use the test bed as our spacecraft for these tests. It's running just like it was approaching Mars. So it's sending us information. We can send all that data up here, and it looks to us like the spacecraft, even though obviously it's sitting on the ground.
Flight nav, go ahead.
We also have simulated data for what the DSN would be getting for navigation data, for example. And we combine all that together pretty intricately, actually, so it really feels like we're actually there, and we're actually getting ready to land on Mars.
Vehicle started, has a proper separation, comes back green. We have touchdown, flyways begin. Safe on the surface of Mars. Congratulations.
This one is what we call the nominal ORT, where everything just goes exactly the way it's supposed to. The spacecraft behaves perfectly, the navigation is very straightforward, and so there's no surprises.
Everything was as expected. Very good landing.
Next time we'll have a group of gremlins throw some curveballs at us, basically, at the team, to make sure that they can respond if the spacecraft has a problem, to prepare the team for what they'll have to do on actual landing day.
All right, looks like from all the data that we have, we are nominally on the surface of Mars.
So one of the things that they have to do is it's not something that is just left behind. So there's enormous amounts of planning. All of these spacecraft have huge staffs, and they've got to do it's an enormous amount of work just to get these things rolling. So let's actually leave you with one thing before we're done. And then I'll take a couple of questions on it. But let's look at Curiosity launching to Mars. This is on November 26th of last year. So remember we saw at the beginning it launched, and then this was the thing that the
5 seconds. Spacecraft set. Achieved our targeted roll rate. Spacecraft separation. And confirmation down on the video system. And the vehicle has debunked.
So that was the live feed on the 26th of last year, on November 26th. So the whole goal is that it's not just a small endeavor. When we look at what we're looking for, it's these technological achievements, these machines that we build. They're our eyes and ears on the other planet. They're the things that go out and reach out and touch for us. Because one day we might actually go to Mars. That's another thing altogether. But to get people to Mars, you have to first figure out if it's a habitable place, if it's a place you can actually go to. And maybe you're my age. You'll be talking about manned missions to Mars. And who will be the astronauts going to Mars? I don't know. Maybe there will be somebody in this room. That's a shame. So, but Mars missions are innately dangerous. They're innately exploring. Our drive and our compulsion to actually go out and look for things out in space, and actually discover where we came from. Did we actually come from Mars? It's an actual question. Maybe we'll know. Okay. Thank you. Well, if anybody has any questions about Mars or the solar system or life in the universe, I'm glad to entertain them. Yes?
Have there been any projects to actually return from Mars? I know that we're only sending robots first to just get there and
Right.
observe and study, but has there been any projects to actually get off of Mars and back to us?
That's a good question. The question was, is there anything for like a sample return?
Yeah.
And the answer is yes. NASA does have on its books a sample return mission, which in addition to making a large lander like we saw, like Curiosity, but they would also land a rocket next to it. This rocket then would take the sample, grab the rocks, put it inside the rocket, close the door to the rocket, fire the rocket, and come back to Earth. Now that's an enormous undertaking, and it hasn't been, there's no funding for it at this point, but there's designs on the table, and the soonest it would launch is 2030.
Oh, wow. And the reason I asked that is because, like, I figured if they can find water and other bacteria on Mars and bring it back, I'm pretty sure by 2030 we'll have the technology to, like,
We
you know,
sure
at least
would.
do something with that
Right.
bacteria. Maybe, I don't know, bring it back to
Well,
life or something.
it also begs it, now the reason to do a sample return is, let's say there is a sample of bacteria-laden or fossilized bacteria rock. There are certain ways that proteins in our bodies, the DNA that makes us up, there are certain ways that these molecules and atoms can be arranged. And you can think about it like this. You can arrange the atoms such that they're either left-handed or right-handed, meaning if you turn them, they look what they rotate. You can't rotate a left hand such that your fingers look like it. So they're mirror images of each other, these molecules. All of the organic material, all the organic molecules on Earth have right-handed, we call it chirality, which means it's basically all the molecules are arranged in this way, and no proteins or no organic molecules have their mirror image. In fact, if you were to eat an organic plant made out of left-handed stuff, you couldn't digest it. You couldn't digest it. It would be undigestible. So, if we were to go to Mars, and if we were to find fossilized bacteria of DNA that's left-handed, and ours is all right-handed, the molecules are set up that way, that would show that life arose independently on Mars and on the Earth, and they were completely separate. However, if they're both right-handed, guess what? They're Martians. Isn't that interesting? Or at least that's really good evidence for it. So sample return is the next big step. And yes, none of the landers, none of the rovers have come back, nor shall they. But maybe one day there'll be an astronaut walking around on the surface of Mars, and there'll be a fence around Spirit and Opportunity saying, here, 90 years ago, we landed first. Another question? Yes?
Will Curiosity be studying the moons of Mars?
No, that was actually the moons of Mars. Will Curiosity study the moons of Mars? The moons of Mars, Phobos and Deimos, are a pair of asteroids that Mars captured. The Russian Space Agency recently launched and lost the Phobos Grunt mission, and Grunt means ground in Russian. And what they wanted to do is take a lander and put it on Phobos. So they didn't actually succeed. It actually didn't leave Earth orbit. What we just saw in the video was exactly where the Russian Space Agency failed, that exact moment. And that's why they showed it on JPL, because it's like, at least we got that. We might lose the lander, but at least we got that. Thank goodness. And that was actually kind of a directive from a NASA director that came out from Charles Bolton. Put that on the air now. We did that at least. So that was important. So, but their mission would have gone to Phobos, landed on the surface of that asteroid, and taken samples and looked at that. That was the goal. So, in fact, asteroid studies are a significant portion of what NASA is doing as well. The Dawn mission is currently orbiting Vesta, and will soon depart Vesta and go to Ceres, the next largest object in the solar system. There's also other missions, the Epoxy mission and Stardust Next, which have visited comets. There's the New Horizons mission on its way to Pluto. Juno is on its way to Jupiter. Messenger is extended mission, which is currently orbiting Mercury. What we're currently in is what's called the year of the solar system that NASA has. And the year of the solar system is one Martian year, which is 22 months. So a 22-month year, we're looking at all the NASA missions that are out there. And Juno will arrive in 2015. New Horizons will arrive at Pluto in 2015. Messenger is going on for another year as it studies Mercury's first time close up. The only spacecraft to ever orbit the planet Mercury. And here's the funny thing about Mercury. Closest planet to the sun has ice, water ice on its poles. Water ice in the craters of Mercury. In fact, the craters in the north and south pole of Mercury are colder than Pluto. That's a weird thought. In fact, you're looking at a picture of Mercury right in the background there. That's a picture of Mercury taken by the Messenger team. Orbital insertion was on St. Patty's Day last year, and we held a big event at the Museum of Natural History. We certainly could show them up by doing a curiosity event here. Because the Museum of Natural History is not doing an MSL event next year. I mean in August. They're not doing one. So it's left William Paterson University to do it at 1:30 in the morning in August. Boy, yes. Do we know what made Mars? Ooh, that's a good question. So what made Mars? All the planets formed a long time ago. So let's go look at that. I'll bring that up for you real quick. Yeah, let's see if I can do that. Well, where the planets came from is, let's bring it up. It's the origin of the solar system. I'll get that for you. Don't you worry. About 5 billion years ago. I want to show you the pictures because it's good to have the pictures. Hold on. Give me a second. It's a really great. The question was, do we know where Mars came from? And the answer is, kind of. That's a short answer. Let's see, let's go down to today. And there we are. It's going to be one. That might do it. Yes, thank you. I know what you're thinking. Okay. Now, the short answer is, I'll give you a short answer and I'll give you a long answer. So, here's the picture of all the planets in their orbit around the sun, with Mercury and Venus and Earth and Mars close up, and Jupiter and Saturn all far away. Where we started from was about 5 billion years ago. There was no sun. There were no planets. They hadn't formed yet. What we're looking at here is a picture taken by the Hubble Space Telescope in '95. And what we're looking at is a gas cloud. And this gas cloud, see this little nodule right here, right there? The entire solar system could fit inside the tip of that gas cloud. This little tip right here, the entire solar system. This is a place where stars are being born. When this picture was taken by the Hubble Space Telescope in 1995, it was called the Pillars of Creation, because inside of this are where stars are forming. And they form out of huge clouds of gas and dust. This is light years across. It takes years for light to go from here to here. And all the entire solar system is inside that little tiny thing. It's a lot of, this is a big picture. So when we look at that, it doesn't sound right. But we're looking at something that's so very, very far away that it looks small. So it's really far away. So about 5 billion years ago, the cloud collapsed. And as it collapsed, first it formed the sun. And some of that material that didn't fall into the sun made all the planets. The rocky stuff, which could stay, like rocks, really hot, that stayed close to the sun. But stuff like water and water, actually, stayed far away from the sun because it didn't boil away. So what happened was all of the rocks formed close to the sun. So we had the sun here, rocky material here, formed crashing stuff, and all of a sudden they all formed together. Little rocks fall together under gravity, then they stuck together and they crashed into each other and make larger and larger and larger things, and eventually planets formed. And so what we're looking at here is, this is a picture of the early solar system, maybe 5 billion years ago. This is an artist picture, not a real picture, but this is what it would look like if we went back 5 billion years and looked at our early sun. And this is what it would look like a few million years after that. And then if we look out into the solar system and go deep into the asteroid belt, which is where all these other planets are, we find the pieces of planets that never fell into becoming other planets. Those are the asteroids. That's the little thing that guys want to go off and mine and make money out of. But these asteroids are leftover debris from the formation of the solar system. So when Dawn goes and visits some of these asteroids, and these are all Vesta here, When Dawn is visiting Vesta, we're looking at a place that is over 4.5 billion years old. And you can get online from meteorite dealers pieces of this. And I own a piece of this asteroid. Vesta. We'll look it up. Dawn of Vesta. Very good question. Yes. Yeah. On Mars? It's about the same. They're almost identical. Mars days are about an hour longer. So everybody on the Mars team slowly phases out of everybody else's life and end to it because they got to live on Mars time. So it's like, oh no! So everybody's up when they're asleep, and they're asleep when everybody's up. So it's a little bit of a pain to be on that. And that was very difficult for the Mars Exploration Rover team. The question was, what's the length of day on Mars? The Mars Explorer team, when Spirit and Opportunity landed, they expected to only have to work for 90 days because they figured that they would be covered by dust and then they would, their solar panels wouldn't work. Well, 8 years into their job, because Spirit only went out about a year and a half ago, but Opportunity's still going. These are, without exception, the most successful exploration vehicles ever. So yeah, it's just about the same as an Earth Day. Pretty cool. Yeah. And Mars, let's look at Mars. Here's another thing. Let's go look at what it looks like sunset on Mars. Yeah. Sunset on Mars. Here's sunset on Mars, view of Opportunity. See that kind of pinkish glow in the background? It's kind of a reddish pinkish glow. If you were on Mars, the sky would look pink. And this was, they put some music to it just for fun. This is a good one. In fact, Opportunity has also seen Earth from Mars, and it looks like a tiny, tiny dot. And this, of course, was Christmas time when they did this. Notice it doesn't look as bright, nor as large. So the sun looks smaller because Mars is farther away. Yeah, I did. All right, we did this right around Christmas time in 2010, so of course. Great question. Any others? Yes? How do they get the names of the planets? Wow, that's a good question. They're old. These names are really old. They're names of Greek and Roman gods. And they've been around the names have been around for the planets that we know, called them classical planets. Mercury, Venus, Earth, not really even Earth, Mercury, Venus, the Moon, the Sun, Mars, Jupiter, and Saturn have been known for thousands of years. There's stories in every great religion and in every great culture that has stories and names about them. But the names of Jupiter and Jove are from Latin and from Rome. All of the others are ancient names from there. And different cultures have different names. But internationally, we now call them by these names. But if you were to go to different places, they would be named different things. And it's interesting that the definition of a planet has changed in time, too. We used to think of the moon as a planet, or even the sun, but now we don't. Okay, cool. Yes?
Why do people look for life on Mars and not on other planets?
Oh, that's a good question. All right, yeah, you opened up a can of worms, didn't you? Can of worms. Why on Mars and not elsewhere? Well, Mercury's too hot. The surface of Venus is about 800 degrees Fahrenheit, and is a runaway greenhouse effect, so no fly zone. The moon doesn't have an atmosphere. Jupiter is a gas giant with no surface. However, Jupiter does have a beautiful moon, Europa. And Europa has a liquid water ocean underneath its ice, and so there's a mission on the books to go drill down through the ices of Europa and look underneath that. Saturn's moon Enceladus has liquid water ice jets, nobody knows. But basically, you can get to Mars. It's hard to get to anyone else. You get to the moon, you get to Mars, everybody else is tough. Yeah. Another question? And then I guess? Yes. How far away? Okay. Well, the Mars is about, wow, how far is it? Well, it's about 1.5 times the distance between the Earth and the Sun. So it's about 150 million miles from the Earth. But yet traveling at 17,000 miles an hour, it takes 8.5 months to get there. That's far. It's going to go about 100 million miles to get there. A long trip. But in the scheme of things, sometimes it's on the other side of the sun from us, and sometimes it's on the same side. So it depends on where it is in the orbit. But in general, the average distance between the Earth and Mars is about 150 million miles. And in general, the distance between the Earth and the Sun is about 93 million miles. Good question. Yes?
When you landed on the moon, how long was the duration of that trip?
Oh, about 3 days. They took 3 days to get to the moon because they didn't want to go so fast that they couldn't stop. See, it's like this crazy thing. When the astronauts went around the backside of the moon, they had one shot to get it right, or else they would not come home. In fact, the astronauts on board all of the Apollo missions had little bottles of cyanide. For obvious reasons. Because if you miss the moon, see ya. Literally. That was something that was luckily never had to be dealt with, but that's a good thing. It's a good thing it never had to be dealt with. Any other questions? Yes? How long does it take the light to get to the sun? A light. Okay. A light year is the distance it takes. Is the distance that light travels in a year. So that's the time distance between stars. The distance from the sun to the Earth is about 8 light minutes. So that's what so it's 8 light minutes to the Earth from the sun, but it's about 11 light minutes to Mars from the sun. So it's about 7 minutes in general for light to get here from there. Yes?
What is the atmosphere of Mars made of?
The atmosphere of Mars is about 1% of the Earth's density. So it's a very, very, very thin atmosphere, but it's almost all carbon dioxide. Almost all carbon dioxide. Now we think of carbon dioxide as a global warming gas, but it's so very thin that it can't hold on to the heat. So it used to be much thicker in the deep past, about 3 or 4 billion years ago, but now it's much thinner. It used to have a lot more water vapor, but it doesn't, the atmospheric density is more like you'd expect at the highest altitudes of where planes fly on Earth. The stratosphere. Any other? Yeah.
Yeah, I'm curious. Is the Russian space program as advanced as NASA?
It depends. Well, I think they have some problems. And it's not that the Russian space program has lost a number of vehicles recently, and they've had some significant setbacks. But the world is relying on them. So that's a big. There's a lot of political and economic things to deal with, and the recent failures by Roscosmos are why the Falcon X program has been stepped up a year, and the SpaceX group has been stepped up because they don't want to rely on that. And the Orion vehicle, which is the next vehicle for human spaceflight from NASA, that's why they've been accelerating it. Because if you have 3 failures in 1 year, you've got to look really careful. Good
But
question.
isn't that our next mission as far as manned mission?
The both President Bush and President Obama have given directives to try to go to Mars as a directive or to an asteroid. And those are both extraordinarily difficult missions. And I think that it would be a good thing to try to return to the moon because the moon has not been sampled at all. It's like saying I've been to the Earth and you've only been, well, it's nice to go to William Patterson University, but if you've only ever been on the campus of William Patterson University and said, I've been to Earth, Now, we've got a very diverse campus, and you meet a lot of different people, and it's a wonderful campus, and there's lots of cool buildings and people, and they get food from all sorts of places, and there's a good Chinese cultural center, but you know, you've not been everywhere. So, we've not been to the most interesting places on the moon, we've only been to the places we could get to easily. So, it's a good question, and it really gets at the heart of it, because it is a governmental agency. Yeah?
Is there a project to replace shuttle program?
A project to replace the shuttle program? Yes. It's called the Orion Project, and it's designed to be able to ferry people to the asteroid belt, at least that far, or to Mars. And the Orion module is scheduled to be, it's been doing drop testing at Wallops Air Force Base, and its goal is to be able to be ready to fly within 5 years. And the module itself is ready for the capsule, so they're going back to capsule-based flying, as opposed to a shuttle. Shuttle was only low Earth orbit. And one thing that's really scary about the shuttle is that when it was designed, this particular shuttle mission, this design, was only designed for 150 flights. Only. And inside of that, there was a 75% chance of 2 catastrophic failures for 150 flights out of 5 orbiters. That was the statistics. Sad. Spaceflight is extraordinarily dangerous. Extraordinarily dangerous. And you can't just get, if you want to do anything out of low Earth orbit, we really haven't gone back to space. We've gone back to low Earth orbit. So the Orion module is a return to space, like the Apollo program. That was a return, that's space mission. So the Orion module is a return to space. And the shuttle was a big bust. It did a lot of great things. It was able to assemble the space station, put Chandra up in orbit, put numerous things in orbit. But it wasn't never designed to actually go places. Yes, we have one? Yeah.
How long is the Curiosity rover going to stay to explore Mars?
It'll stay there forever, but it'll run for about 2 Earth years before its nuclear reactor runs out of power. And we'll take one more question, and that'll be it. Yeah.
It's not related to Mars, I'm sorry, but in your opinion, is there such thing as global warming?
Without exception, yes.
Really?
Without
I'm impressed the way I am.
Well, that's because of what's called that's an Arctic oscillation that comes down. In fact, when we're looking at global warming predictability scenarios, do not show that this place here will be warmer. What it shows dominantly is that there will be an increase in the amount of water vapor in the Earth's atmosphere, which destabilizes the entire global system. And why we're actually cold is because the Arctic oscillation is much more variable. And so what we're experiencing is a result of that. And another event of global warming is sea level rise. And the people in Norfolk, Virginia are having problems with that today. More flooding's happening. And in fact, this city itself is going to be having more direct result because of increased rainfall, less variability and less reliability in weather. The desert Southwest is predicted to have drier climate, which is occurring.